Hello everyone, welcome to my very first video. I'm really stoked to start this YouTube channel. I have been thinking about starting a YouTube channel for mathematics and physics for quite some time now, and I'm really glad that I'm doing it now. My name is Jagpat, and I will be talking primarily about mathematics and physics in this channel, mostly mathematics, and I will be covering wide range of topics from basic maths to advanced mathematics, advanced calculus, and we will also be talking about some topics from mathematics Olympiad as well. So it's going to be really fun. Today's topic is Feynman technique. We are going to talk about this little neat trick of calculating some advanced integrals. So first and foremost thing, what is a Feynman trick and why do we call it a Feynman trick? See, Dr. Richard Feynman was the first mathematician or physicist to really popularize this technique, but he was not the first person to use it. He read it in a book called Advanced Textbook for Calculus by Woods. All right, so what is Feynman technique? Feynman technique is basically a trick to calculate some advanced integrals, and we can summarize this idea in a single line: differentiation under integral sign. So this is exactly what we are going to do. Let's say we have something to integrate. I have something like this, sin x over x dx minus infinity to infinity. This is a very popular integral. That's why I'm taking this as a reference example. So what is Feynman technique? It says that first and foremost thing, we are going to artificially introduce a new variable. You can call it anything. And after that, in the next step, we are going to take derivative inside the integral to build a differential equation, and then we will solve that differential equation. So most of the action happens here. Step number one, we have to introduce a new variable. This is where we have to apply some of our basic knowledge of integration and a little bit of common sense. Second step is more of a mathematics. We just have to take the derivative and go with the flow. All right. Let's take one example, and this will be a little bit more clear. I'm going to start with my personal favorite example. It goes something like this. We have to evaluate an integral of x raised to the power. It could be anything. It could be x raised to the power 1. It could be x square. It could be x cube. Let's go with x cube, 0 to 1. This is the integral that we want to evaluate. First and foremost thing, if you try to solve this integral using our standard methods of integration like substitution of variable or integration by parts, you are going to have tough time. You most probably won't be able to solve using these methods, and that is where Feynman integral comes in. So let's use Feynman technique to solve this integral. First and foremost thing is we have to think how we are going to introduce a new variable. That is where your what can we say, integration instinct comes in, or you can call it common sense comes in. How do we introduce a new variable? I'm going to do something like this. Let's talk about the integral of x raised to the power t minus 1 over ln of x. We will keep the limit same as before, 0 to 1, and I'm going to call this integral as f of t because the answer that we will be getting will be in terms of t, right? This is the first step. This is the most important step because if we don't choose a proper way of introducing the new variable, then the whole integral kind of will get messed up. Second step is very simple. Take the derivative d by dt of f of t, and when we take the derivative inside integral, it basically gets converted into a partial derivative, something like this, ln of x dx, and let's go with the flow. Now right hand side is where most of the action is going to happen. If I take the derivative of this function, you can see right away why did we introduce variable t in the exponent of x, because when you differentiate this function x raised to the power t, we are going to get something really amazing. X raised to the power t ln x. Since we are partially differentiating with respect to t, x is going to act just like a constant number. So you don't have to worry about ln of x. And we get something like this. And you can see the beauty of this integral, that ln x gets cancelled out from numerator and denominator, and we get a very simple integral. We can integrate it, solve it, we will get 1 over t plus 1. See what we have done. We have introduced t in such a way that after differentiation, ln x gets cancelled out, and as you can see, ln x was the main problem in our integration. Ln x was the term because of which we were not able to use our standard methods anyway, right? So if we evaluate it, we are gonna get f dash of t equals to 1 over t plus 1, and yeah, this is it. Now from this expression, let's see, we have f of t. Our goal is to calculate I, and I is nothing but f of 3. First thing. Second thing you can notice is that if you substitute the value of t as 0, if you try to calculate f of 0, you can very easily see that x raised to the power 0 minus 1 basically is equal to 0, and this whole integral vanishes to 0. So f of 0 is 0. This is a very important step when using Feynman technique. We have to set a boundary condition so that we are able to solve the next step, which is going to be integral of this function. We have f dash of t equals to 1 over t plus 1. Let's integrate it. We will get ln of t plus 1, and don't forget the integration constant c. Integration constant c is something that we have to take care, and for that we will use the boundary condition that if we substitute t equals to 0 here, we will get f of 0 equals to 0. So f of 0 is equals to ln of 0 plus 1, which is 0. This will give us c equals to 0, and we will get f of t equals to ln of t plus 1. Now don't forget that what was our original integral. Original integral was something like this, 0 to 1 integral of x cube minus 1 over ln x. And we can get this original integral by putting t equals to 3. F of 3 is our integral that we wanted to calculate. Right, so this is what we have gotten, and you can see Feynman technique really made the day. It just reduced this complex integral into a simple two-liner integral. I hope you like this video. And there's one more thing I wanted to tell actually. I chose this example because I saw one question, I equals to integral 0 to 1 x minus 1 over ln x dx. And this question was asked in IIT JEE examination. I think it was 2019. I'm not sure about the year, but this is the question they asked. And you can see this integral is sorry, this integral is nothing but f of 1, the function f that we calculated here. So if we substitute t equals to 1, you will get f of 1 equals to ln of 2. This is what we are getting, right? So this was Feynman technique. I really hope you guys liked the video, and don't forget to subscribe the channel because I'm going to upload a lot of amazing videos of mathematics and physics. And please don't forget to share it with your friends. And again, thank you very much for watching. Have a great time.